The problem we have with process payment and process refund is that we have some kind of code duplication in there. We have the same kind of checks which we run in there. And that's bad, because that means that we repeat ourselves, which we of course shouldn't do, as we learned. The problem just is that for these different checks, we then do different things. We process credit card payments and credit card refunds, which are different functions, which, of course, that should be easy to imagine, do totally different things in reality. Here we just log something to the console, but that's just some dummy code. In reality, there's a big difference between charging a credit card and refunding a payment to the credit card. So it makes sense that we have different functions here, and we probably won't be able to merge these in an elegant way. Though there actually is something we could consider doing to slim this code down and to make it more readable. We could kind of inverse our checking logic. Now, what do I mean by that? Currently, we first check whether we have a payment or a refund, and then we process this payment or a refund, which means we then have these checks. Of course, we could theoretically also first check what the payment method is, since we have the same methods for both payments and refunds, and then only check if it's a payment or a refund in the second step. To check this, I will actually get rid of checking for is payment and is refund, though I will keep these functions, but instead I'll add a new function where I want to check whether a transaction uses credit card, PayPal, or a payment plan. So we can name this function uses credit card, and we would get a transaction here. And then I want to essentially return this check here. So I return transaction method equals credit card. And we can repeat this function to also have a uses PayPal function where we check for PayPal as a method, and to have a uses plan function where we check for plan as a payment method. We could even merge these together and just have a uses transaction method function where we get the transaction and the method, and we then have this comparison here. It's up to you which approach you prefer. With such a method added, though, we could go to process transaction and not check first whether it's a payment or a refund, but instead simply check if we use a certain transaction method for the given transaction. For example, if we use credit card. And if we do that, then we'll do something here. Else if we use another method, let's say PayPal, we do something else. And last but not least, if we have a transaction where the method is plan, we do yet something else. Now, what are these something else's which we want to do? Well, that is now our processing for credit card transactions, PayPal transactions, and plan transactions. So these would be new functions which we can add. We can add a new function here, maybe above process payment, which is named process credit card transaction. And here we get our transaction no matter if it's a payment or a refund. And we can do the same for PayPal to have a process PayPal transaction, and the same for a payment plan, so process plan transaction. And we'll add logic to these functions in a second. So now we have these three functions, and these are the functions which we want to call here. So we want to process a credit card transaction here and forward the transaction. In the next if branch, we want to process a PayPal transaction and forward the transaction. And in the last branch, we want to process a plan transaction and forward the transaction like this. Now we will eventually remove this code. I'll just leave it here for reference for a second. But now we have these functions which are being called depending on the transaction method. So the check which we previously had inside of process payment and process refund now moved up one level directly into process transaction. Therefore, to fully invert our logic, we now have to move the payment and refund logic down one level, out of process transaction into these process credit card, PayPal, and plan transaction functions. Hence, now in all these functions, we have to check whether we have a payment or a refund. And that is what I meant with we invert the logic. We will still have some duplication. There is no way around that because we had two dependent kind of if checks. But now we have the more complex if check where we replicated 3 different checks at a higher level, and we have the easier check where we only have 2 options at a lower level. But on the other hand, we execute this check 3 times now, so overall we can question whether we gain a lot. Nonetheless, let's finish this before we look for an even more elegant solution. So here, in process credit card transaction, we can now check if we have a payment using this isPayment function which we defined before for our given transaction, or if we have a refund for this given transaction. Or else we know it's invalid, and then we can show an error message and simply, well, use this code from before. Show error message, invalid transaction type, and pass the transaction as well. Like this. And now if it's a payment, we know it's a credit card payment, so here we can call process credit card payment. And that's one of the functions which existed right from the start, one of these dummy functions. If it's a refund, we know it's a credit card refund, so we can call process credit card refund. And now we can copy that code into the other method functions here. So here we call process PayPal payment and process PayPal refund. And here we have process plan payment and process plan refund. And we can now get rid of process payment and process refund down there because we don't need these functions anymore. So what we did now is we inverted these checks. Now we check for the method at a higher level and then for the type of transaction at a lower level. Hence we can now remove this if check here from the process transaction function because that's the check which we now have in all these method specific functions. Nonetheless, of course, we have duplication here. And just like this, we also won't be able to get rid of it because we're in the end just moving around checks. And it's up to you which kind of solution you find easier to read. If it was the one from before, where we had the payment refund check at a higher level and we checked for the method at a lower level, or if it's this solution where we do the opposite. Nonetheless, this is our current state, which we will now use to build up on. Before we're going to explore how composition and polymorphism might be able to help us with that problem of duplicated checks, which I outlined over the last lectures, let's see how utilizing errors can help us with our code overall. Because one mistake which quite a lot of developers make is that they don't utilize errors and throwing custom errors enough. And errors as well as error handling is really your friend. Because throwing and handling errors in the proper places can actually replace useless if statements and lead to more focused functions. And here's a simple rule. If something is an error, if something has an error character, make it an error. Don't try to solve it with an if statement. For example, here is a short snippet, which we don't have in our big example, but which you could see in other programs as well. Here we're checking whether something is an email, and if we make it into this if block, I do return an object here where I assign some code, probably some kind of error code, and a message. And then in other parts of our application, we could check for this object, check the code in there, and then run code depending on whether we have code 422 or if we maybe were successful. So in the end, what we're doing here is we're constructing an error without really using the built-in error mechanisms all modern programming languages offer to us. This here would be a better way of writing this. We're having the same check, but now I'm constructing a real error building up on the built-in error object, which also all modern programming languages give you in some way. I then add extra data to this error object, in this case a code field, which I set to 422, and then I throw this error. Now this again is JavaScript, but similar mechanisms for building and raising your own errors exist in all programming languages pretty much. You can always build errors either using built-in error objects or building your own ones to add any data you might need to add, and then you can throw these errors, and then, and that's the key part, you can also handle these errors. And if we come back to our example, we have a couple of places where we are doing error-like stuff without really using errors. For example, here in process transactions. Here we are checking if we have no transactions, and if that's the case, we're printing the error message. Now we could argue that from a clean code perspective, printing the error message should actually not be part of processing the transactions. Processing the transactions should really just do that, go through the transactions and do something with them. Checking whether they are valid would be okay, but handling the they are not valid case, that is actually too much. It would be better to do that in the place where we call process transactions, which is this main method I provided to you right from the start, where we also have some dummy data. And that's exactly where we can use proper errors instead of doing it like this. Now, one naive solution would be that we actually return an object here where we do what I showed you on the slide. And we have a code of 1, let's say, which stands for we have an error. And I then have a message of no transactions provided. And we return this in the error case. And then here in the main function, where we call process transactions, we get the result back from process transactions. So this object, we store it here. And then we check if result code is equal to 1. And if that's the case, we know we have an error. And then we show an error message. And the message which we do show also comes from the result. And it's that message field. This is what we could do. This is how we could handle this with an error-like approach. And it is better than having the message here, or the logic to show this message here in process transactions, but it's bad because we now wrote code which requires an extra if statement and which doesn't really utilize the built-in error support. Hence, a better way of doing that would be to create a proper error. In JavaScript, we can do this by instantiating the error object. This error constructor also takes the message as a parameter. Then here in JavaScript, we can easily add extra data by setting a property like this, even if it didn't exist before, and setting this to 1. And then we can throw this error. Now, to have an even cleaner way, we could also create our own error class, which extends the built-in error class. But this is the quick way of doing it, and I just want to focus on the general concept here. So now we can remove this return statement. Because of the throw keyword in JavaScript, this code execution will stop anyways as soon as we throw. So this code down there will not be executed if we throw an error. And therefore, this error will then bubble up throughout our application, and we now need to handle it. That's the other part of working with errors. And as in so many applications, we can handle our error by using try, catch, or in Python, for example, it's try except. There we catch our error and we try processing the transactions, where we now no longer get back a result. And instead here, when we catch the error, we show our error message with this show error message function. And this is now a proper way of dealing with this. Now we're using the built-in error mechanism to ensure that the error message is triggered in the right function and that the error is generated as a real error instead of some dummy object. This is the proper and clean way of doing it. use errors where you have errors. Now, of course, in our demo application here, we got two other places where we in the end are dealing with errors. And that's here in process transaction, this check, where we see whether a transaction is open or not. And then in all these processors here, in all these process transaction functions down there, we also print an error message if we have neither a payment nor a refund transaction. So if we have some invalid transaction type. Again, a better way of handling this would be to generate a real error and then treat it somewhere else. So let's maybe start here in process transaction. If the transaction is not open, then we can create an error, a new error, with a value of invalid transaction type. This is my message. And then I want to throw this error. Here I don't add a code because here for this logic I don't really need it. That was just from the example before, showing you that you could add this code, even though we also don't use it here, by the way. We add it, but we never use it. So you could remove it here as well. We definitely don't need it down there, but now we're throwing an error instead of handling the error here. Now we can do the same here for process credit card transaction and process PayPal transaction and so on. Here we can also create an error, a new error with this text. And here we can add some extra data, for example, the item which was responsible for this error, which is the transaction that caused this. And then we throw this error. Now we just have to repeat this code in all these functions, and as you know, repeating code like this is bad. So what could we do? Well, we could again utilize a guard. We could remove the code from here and remove this else statement in all these process functions, and instead move that here to process transaction. Before we actually start triggering process credit card, process PayPal, and process plan transaction, we could check whether we do have an invalid transaction. Simply by adding an extra guard here. Here we could check if we have neither a payment nor a refund, because that is the check we had in these nested functions before. And if that's the case, we want to generate and throw an error. So we added a new guard to move some nested logic out of these nested if statements to a higher level, because we can already perform this check here and check for whether we have a payment or a refund. And if neither of the two is the case, I want to generate an error. Now we generate and throw two different errors here in process transaction. The question is, where do we now handle them? And the answer is not here in this error handler which we added before. Because we must keep in mind that these errors are thrown for single transactions. So they should not stop processing all transactions. They should just stop processing this specific transaction. Hence, we want to handle the errors here in this for loop. Here we can add a try catch block and try processing a transaction, but catch an error if we got it. And then show an error message here, forward the error message and the error data, or the error item was the name I picked. This may be undefined for some errors, but that's no problem because we have a check for this inside of show error message. So now we moved this around and we're using proper errors for, well, working with errors, because that is what we have here. And doing that instead of using if statements where we then log something in place is definitely recommended. So by now we already refactored a lot. I'm fully aware of that. But this is how you do write clean code. It's a step-by-step process, which is why I'm showing it in great detail here. Because that is what you will do ultimately when you clean up your own code. It's about trying out things, being creative, and moving things around. And speaking of moving things around, We now use errors, which is great. But now we have all that code for creating errors side by side with code that, for example, dispatches different process functions for different transaction methods. This again is mixing different levels of abstraction. So we should consider splitting our functions. For example, here in process transactions, where I check for whether my transactions are empty to then create an error. We can create a new function which we could name validate transactions, where we get all the transactions. And then we move this code, where we generate this error, into this function. Then here in process transactions, we can simply call validate transactions before we go through this for loop. The great advantage of this approach is not just that process transactions is now slimmer, though we should forward transactions to the validate transactions function, but also that because we use real errors and we throw this error, we use a built-in mechanism in the programming language which will ensure that this automatically bubbles up. So it will just bubble through process transactions, canceling this function as well if an error is generated inside of validate transactions, moving up to the next function until it is being handled, which in this case it is here. And this, of course, is great. This here, of course, should be transactions, by the way, not transaction. Now we could argue that we have mixed levels of abstraction here, calling is empty and then this low-level code of creating the error and adding a code. And therefore we could also add another function here where we build this error. You could absolutely do that, but I will not do it here. I think it's too much splitting, and if you would want such a helper function which builds an error, I would recommend that you simply create your own error class which you instantiate here. So I will leave it like this. Nonetheless, we have some extractions left to do here for process transaction. There we check whether it's not open or if it's neither a payment nor a refund. And we can outsource these validations as well. So we can add a new function here, which we name validate transaction, for example, receiving the transaction as a parameter. And now we could either create one function for each check here, or we take both checks and put them into the same function, which I will do here because we're doing the same kind of work. We're validating a transaction, just with different checks, and therefore having this in one function makes a lot of sense to me. And now we can just call validate transaction here before we then try to process the different transactions. And again, because validate transaction throws an error, if we got an error, this process transaction function execution will be cancelled if an error occurs, and this code will not be executed. Instead, we move up to the next function above it until this is being handled, which in this case is happening here in this for loop. And that now again were more extractions, which hopefully overall help with readability if you would read this entire code top to bottom. So now we got all this nice error throwing and error handling code. I got one last rule or recommendation related to error handling. And that is that error handling actually is typically considered to be one thing when we talk about functions doing one thing. And what's the implication of that for our code? In the main function at the top, we have all this dummy data, but then here we have our try-catch block. And since this is just dummy data here, we can basically ignore it. This could also be in the try block where we then maybe try to fetch it from a website or anything like that. So here we in the end have just one thing. We just have the try-catch block inside of this function. Of course, we do something in the try and in the catch case, but that's the entire idea behind try-catch. It's not about not doing anything in here, it's just about not doing anything in addition to this try-catch block, which is the case here. But for process transactions, it's different. Here we validate, then we have a for loop, And then in there, we have try catch. So here we are doing more than just error handling. We are also looping and validating. Now, one way around this could be that we move try catch actually into process transaction. So kind of back to where it came from, you could say. So let me grab this catch block, remove the try block, so that we just have process transaction in the loop again. And now inside of process transaction, we could add a try block here and move validate transactions as well as all this if code here into this try block, and then add the catch block from before with show error message. This could be one way of fulfilling this rule again and of ensuring that we do only one thing. We try validating and then doing this, and if that fails, we catch the error. Now, having this code in here is still not super clean. It would probably be cleaner to validate and then just call another function which contains this code. But the question is, how would we name this function? Is this a split which really makes a lot of sense? We could try it and, for example, add one other function here above uses transaction method maybe, which we name process by method. And we pass our transaction in there, and in here we then check for the method and then dispatch our different process functions. And now we could call process by method here and forward the transaction inside of the try block. And now this is cleaner, and this down there is also clean. And that's how I would recommend that we solve this here, though as always, it always also comes down to personal preference and what you find to be clean and readable. With that, however, we're now really done with all the error handling. Now I want to come back to this problem of our code duplication down there and how we can maybe solve that in a better way. Now let's come back to this problem of having some duplicated code and having all these extra checks for whether something is a payment or a refund. We can solve this problem by utilizing factory functions and polymorphism. And for that, of course, we need to understand what a factory function is and what polymorphism is. A factory function is simply a function which is used to produce something. For example, to produce objects or produce maps, arrays, anything like that. We provide a certain input and it then produces a certain object for us. Polymorphism is a concept to which I will come back to in the next course section, which is about classes and objects. In the end, it means that we can have an object or a function which we can always use in the same way. For example, an object on which we always can use the same method. But what this method does in detail then depends on some other factors. And we can combine this to write a factory function which produces different other functions or objects with functions that we can always call in the same way, but that then sometimes handle credit card payments and sometimes handle PayPal refunds, for example. And that is exactly what we're going to work on now. We're going to write a factory function which creates an object which always will have the same structure, but then different code that executes under different circumstances. Let's go up to the process transaction function again. Here I call process by method to then trigger this function. Now I will replace this function. So we'll add a new one and soon delete the old one. And I will name this function getTransactionProcessor. And this function will be a factory function. This function will return an object, and it will actually return a polymorphic object full of functions which always have the same name, but will do different things. That's the plan here. And for that, we will utilize the fact that in most programming languages, you can indeed use functions like regular values So you can assign functions to variables, to properties. You can pass functions around. And we're going to do that because we are going to return an object full of functions which already exist, but which we won't call in here, but which we will just swap dynamically depending on which function we need. But it will become clearer as we start working on this factory function. And for this, I want to utilize the fact that functions in JavaScript, but also in many other programming languages, are callable, but don't have to be called. And if you don't add the brackets after the function name, you can use them just like any other value, like a string, a number, or an object. So now with that, we can grab this code here and move that into getTransactionProcessor, and then add a new variable here in this getTransactionProcessor function, which in JavaScript we do with the let keyword, which I'll name processors, because we have two possible processors for every transaction, a payment and a refund processor, at least after going through these checks. Now in here, in this object, which I create like this in JavaScript, or a map in other programming languages, I will add two keys. Payment with a value of null initially, so no value, and refund with a value of null initially. Now the idea is that we populate payment and refund with functions as values inside of these checks. So here, if we use a credit card as a payment method, I will set processors.payment equal to process credit card payment. But I'm not calling this function. I'm not adding parentheses. I'm just pointing at it. So this process credit card function, which is defined down there, I'm pointing at it. I'm using it as a value. I'm not executing it. And I'm storing this pointer at this function in this key, in this object or map. So here, I'll then do the same for refund and store process credit card refund in the refund field of this map. Again, just pointing at it. And we can now do this here in all these cases and just point at the different processor functions. So here it's process PayPal payment at which I'm pointing. Here it's process PayPal refund. And here it's process plan payment and process plan refund. So now we're populating this object, and I am simply returning this object thereafter. So in this getTransactionProcessor function, I'm creating this object, populating the different processors depending on the payment method which was chosen, and then I return this. Now with that, we can get rid of the processByMethod function. We should keep the isPayment and isRefundHelper functions, but we can get rid of the process credit card transaction, process PayPal transaction, and process plan transaction functions. So we remove a lot of code here. In getTransactionProcessor, we should now accept the transaction as a parameter, because we're using it here to derive the method. And now we're creating this object here, which we can now utilize by calling getTransactionProcessor here in the process transaction function. Instead of calling processByMethod, we now get our processors by calling getTransactionProcessor and passing the transaction to it. And now we can simply check if we have a payment for the given transaction, in which case we want to call processors.payment and execute this as a function and pass the transaction to it. Else, we can call processors.refund and pass the transaction as a function. And of course, now we can also outsource this out of process transaction to keep it clean, and maybe add a new function here, which we call process with processor, accept the transaction as an argument, and copy our code in there. And now it's process with processor, which we can call here. Though again, you can argue whether this really is a good split or not. It definitely makes this function more readable, but now of course we have to scroll down to process with processor. Still, I would argue both functions are easy to find and readable, and therefore clean. We could also rename these keys here to make it clear that they hold functions, and rename this to make payment and make refund, for example, or process payment and process refund. And of course, then also use process payment here when we store a function, and process refund when we store a function. And with these properties renamed, we can call process refund here and process payment here. But that's just some renaming to make it clearer what's inside of these properties, which we of course should do to write clean code. And now with that, we got rid of these extra nested if checks, because now we're using such a map of functions which we return. So in the end, getTransactionProcessor is a function which just returns a map of other functions. Maybe therefore we should rename it to getTransactionProcessors and also call getTransactionProcessors here, of course. Because now this will give us an object or a map full of functions which we then can call to process the transaction appropriately. And this is a technique we can use to make this code slimmer and to remove all these duplicate checks. Now we're almost done with this long practical section here. There are still minor improvements we could make and you should consider. And that would, for example, be that in showErrorMessage, we sometimes call it with just a message, and sometimes, of course, we call it with a message and an item, which is why we accept both, message and item. Now this is okay, we have this if check here, but we can actually get rid of this pointless if check here if we simply always console log the item, but make sure that the item is never undefined. But instead maybe give it a default value of an empty object or map. And default parameter values, of course, are also accepted and supported in many programming languages. So now we ensure that there always is an item, even if it's just an empty map, which we then therefore output here. So that's a tiny improvement we can make here to get rid of one extra if check. Because as you saw throughout this section, getting rid of if checks can really help with readability. So that's it for this section. It was a long section with a lot of code, which we changed. Now we have this final result, though I will already say one piece is missing. And that would be polymorphism, which also can help us with solving that problem of having duplicate if checks. We solved it for now by having this map full of functions, which works, but there is another approach using classes and polymorphism, which I will also come back to in the next section, however, because the next section will be about classes, objects, and everything we need to know about them when it comes to writing clean code. So therefore, for the moment, this is the final state. And of course you might argue that this is quite a long file with quite a lot of scrolling required to move around. Now, of course, keep a couple of things in mind. For one, we got a bunch of dummy data here, which already occupies 30-ish lines of code. And then we got all these dummy methods down there at the bottom, which we of course also would have in reality with real code in there, but they would probably not all be in the same file. And in general, this long file could be split up. I have an example folder structure here in the final demo folder, which you also find attached. There I have a very lean app.js file where we just have the main function, process transaction, and process transaction. And then all the other functions which are being called in here are in the end imported from other files, which you find in subfolders. For example, the util folder has the error handling function and my validator functions. The data folder simply holds these transactions. And the processing folder has these functions that deal with the direct processing of the transactions. So the validation, and then also for processing with a processor and picking a processor. And of course, in reality, you would split up code like this or in a similar way. because that then makes the individual files easier to read and therefore also helps with achieving clean code throughout your entire project. You don't just want to have one endless file. Of course, for the purpose of this section and for showing everything without switching files all the time, I did do it all in one file. And even if you go through this file, therefore, it should still be rather clean. It reads top to bottom. We have these functions with good names, which we can call. And we used all these functions and all these various concepts covered throughout this course to ensure that we still have a couple of if statements and a loop, but we have less of them and we do combine them in a more structured way to ensure that we have way more readable code, even though it takes up more lines of code, than we had at the beginning. Because this was definitely harder to read and understand and maintain, and it had a lot of duplication inside of it. So now throughout this section, we learned how splitting this up into functions, something we already learned in the last section, and how a couple of tweaks related to if statements and how to name our conditions and so on can help us with turning this into a way more readable and therefore cleaner code base. This course section will be about classes and objects, and about keeping your classes and objects clean and working with objects in a clean way. Now, therefore, of course, it won't matter to you if you're never ever working with classes or objects in your code, but if you do work with classes and objects in any way, even if that's not a 100% object-oriented style, then you will get important information out of this course section. Because we are going to have a closer look at classes and objects, and we're going to learn that we can differentiate between real objects, if we want to call them like this, and data structures or data containers, and what that difference is and why it matters. We'll have a look at a bunch of object-oriented principles, which even help you if you're not following a 100% object-oriented style. We're going to have a look at the solid principles there and at the law of Demeter. And we're also going to take another look at polymorphism and see how classes can also help us with that. It is a concept we already had a look at in the last course section. Now we're going to take another look in this section. Now, this course section will still have a couple of demos and examples, but it will be a bit more theory than the last sections, because in this section we'll have a couple of core principles and guidelines which you should be aware of when working with classes. Now, before we dive into the different aspects I want to cover in this section, let me make one thing very clear. This course section will not teach you object-oriented programming. It will not teach you that. This is not the focus of this section and not the focus of this overall course. The idea of this course is to give you general concepts and rules and ideas which you can follow to write clean code, no matter how you write your code. This course is not focused on object-oriented programming, and this section isn't either. We are going to explore various concepts which come from the object-oriented programming world and which apply to classes, but as I mentioned before, this will matter to you if you're working with classes in any way, even if you don't build your entire project in an object-oriented way. Therefore, we're also not going to dive into all possible object-oriented programming patterns and practices. I am going to cover some important core principles which you should be aware of, but this will not be a deep dive object-oriented programming section in general. That's simply not the idea behind the course. The idea is to give you all the core tools you need to write clean code. And for that, of course, we must not forget that clean code is simply code which is written such that it's readable and easy to understand by humans. Now, all these patterns and principles which exist, they help you write code which is maintainable and extensible. Of course, there is a relation to clean code. If you follow these patterns and principles, you tend to end up with clean code, but you could also follow a lot of these principles and still write bad code. That's why we definitely focus on the clean code part here instead of covering all possible patterns and principles. If you are interested in all these patterns and principles, a course focusing on just object-oriented programming is of course the course you want to take.